The dream of reaching the moon has fascinated humanity for centuries. Early concepts and theories about lunar travel can be traced back to ancient civilizations. For instance, in the 2nd century AD, the Greek philosopher Lucian of Samosata wrote about a journey to the moon in his work True History. Fast forward to the 17th century, Johannes Kepler, a renowned astronomer, penned a novel called Somnium, which depicted a voyage to the moon and speculated about its inhabitants. These imaginative ideas laid the groundwork for future scientific exploration. In the 19th century, the French author Jules Verne captivated readers with his novel From the Earth to the Moon, published in 1865. Verne's story featured a giant cannon that launched a spacecraft to the moon, a concept that, while fictional, inspired many future scientists and engineers. Interestingly, Verne's calculations for the spacecraft's speed were remarkably close to the actual velocities required for space travel. These early concepts and theories, though often fantastical, played a crucial role in shaping the scientific and public interest in lunar exploration, setting the stage for the monumental achievements that would follow in the 20th century. The space race, a period of intense competition between the United States and the Soviet Union, marked a pivotal era in the history of lunar exploration. This rivalry was fueled by the broader context of the Cold War, with both superpowers vying for technological and ideological supremacy. The Soviet Union took an early lead with the launch of Sputnik 1 in 1957, the first artificial satellite to orbit the Earth. This achievement sent shockwaves around the world and spurred the United States to accelerate its own space program. In 1961, President John F. Kennedy delivered a historic speech setting a national goal of landing a man on the moon and returning him safely to Earth before the decade's end. This ambitious objective led to the creation of the Apollo program, a series of missions designed to achieve this monumental task. The program's name, Apollo, was inspired by the Greek god of the sun, symbolizing the light of knowledge and exploration. The Apollo missions were a series of increasingly complex and daring endeavors. Apollo 11, the most famous of these missions, achieved the goals set by President Kennedy. On July 20, 1969, astronauts Neil Armstrong and Edwin Buzz Aldrin became the first humans to set foot on the lunar surface, while Michael Collins orbited above in the command module. Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," were broadcast to an estimated 600 million people worldwide, making it one of the most watched events in television history. The Apollo program consisted of 17 missions in total, with 6 successful lunar landings. These missions provided a wealth of scientific data and brought back 382 kilograms of lunar rocks and soil for analysis. The program also saw the deployment of various scientific instruments on the moon, including seismometers, magnetometers, and retroreflectors, which continue to provide valuable data to this day. One of the most remarkable aspects of the Apollo missions was the sheer scale of the effort involved. At its peak, the program employed over 400,000 people and required the collaboration of more than 20,000 companies and academic institutions. The Saturn V rocket, which launched the Apollo missions, remains the most powerful rocket ever built, standing 363 feet tall and generating 7.6 million pounds of thrust. Despite its successes, the Apollo program faced significant challenges and setbacks. The tragic Apollo 1 fire in 1967, which claimed the lives of 3 astronauts during a pre-flight test, underscored the inherent risks of space exploration. However, the lessons learned from this tragedy led to crucial safety improvements in subsequent missions. The space race and the Apollo missions not only achieved their primary goal of landing humans on the moon, but also left a lasting legacy of scientific discovery, technological innovation, and international cooperation. These missions demonstrated what humanity could accomplish when driven by a shared vision and a spirit of exploration. The journey to the moon is marked by several key milestones and achievements that highlight the ingenuity and determination of humanity. One of the earliest milestones was the successful launch of Luna 2 by the Soviet Union in 1959, which became the first human-made object to reach the moon. This was followed by Luna 3, which provided the first images of the moon's far side, a region never before seen by human eyes. In 1966, the Soviet Luna 9 mission achieved the first soft landing on the moon, sending back panoramic images of the lunar surface. The United States made significant strides with the Ranger and Surveyor programs, which provided crucial data for the Apollo missions. Surveyor 1, in 1966, was the first American spacecraft to achieve a soft landing on the moon, demonstrating the feasibility of landing humans. The Apollo program's achievements are numerous, with Apollo 8 being the first manned mission to orbit the moon in 1968. This mission provided the iconic Earthrise photograph, which profoundly impacted public perception of our planet. Apollo 11's landing in 1969 was a monumental achievement, but subsequent missions also made significant contributions. Apollo 12, for instance, demonstrated pinpoint landing capability by touching down near the Surveyor 3 probe. Apollo 15, in 1971, introduced the Lunar Roving Vehicle, allowing astronauts to travel greater distances on the lunar surface. These milestones not only advanced our understanding of the moon, but also showcased the remarkable progress in space technology and exploration. The journey to the moon was fraught with numerous challenges and setbacks, each presenting unique obstacles that had to be overcome. One of the most significant challenges was the development of the Saturn V rocket, which required over 2.5 million parts and stood 363 feet tall. The complexity of this engineering marvel meant that even a single failure could jeopardize an entire mission. Another major hurdle was the harsh environment of space. Astronauts had to endure extreme temperatures, radiation, and the vacuum of space. The Apollo 13 mission in 1970 highlighted the dangers when an oxygen tank exploded, crippling the spacecraft. The crew's safe return was a testament to human ingenuity and the effectiveness of emergency protocols. Statistically, the Apollo program had a budget of approximately $25.4 billion, equivalent to over $150 billion today. This massive investment underscores the scale and ambition of the endeavor. Additionally, the program involved over 400,000 people, including engineers, scientists, and support staff, working tirelessly to ensure mission success. Despite these challenges, the Apollo missions achieved a remarkable safety record, with only one fatal incident during Apollo 1's pre-flight test. These setbacks and challenges ultimately paved the way for future successes in space exploration. As we look to the future, lunar exploration is set to enter an exciting new phase. NASA's Artemis program aims to return humans to the moon by 2024, with plans to establish a sustainable presence by the end of the decade. This mission will include the first woman and the next man on the lunar surface. Additionally, private companies like SpaceX and Blue Origin are developing their own lunar landers, promising to revolutionize space travel. The Lunar Gateway, a planned space station orbiting the moon, will serve as a staging point for missions to Mars and beyond. With international collaborations and advancements in technology, the next decade promises to be a golden era for lunar exploration.